Hey everyone, welcome back to AthlyticZ. Today we're diving into one of the coolest ways to combine data science and sports by visualizing NBA shot data using Python. In this video, I'll walk you through how to load Steph Curry's 2023 shot data, clean it, and visualize it with bar charts and even a heat map over a custom-drawn NBA half-court. If you love Python, basketball, or both, you're gonna love this tutorial. Let's get started. All right, so let's first get familiar with the dataset that we'll be using for this video. We're gonna be using this NBA player shot dataset from Kaggle. The link for this dataset is in the description, so you can download it and follow along. Once you have the dataset downloaded, go ahead and open it up and take a look at what you're working with. The first two fields are top and left. These are the vertical and horizontal positionings on the court where the shot was taken. So having these XY coordinates enables you to essentially graph the position of each shot. The rest of these fields are pretty self-explanatory. One caveat is that there's a field in this dataset called LeBron team score. And I believe this is a mistake. I think it's supposed to be Curry team score, but we won't need this field for any of the examples in this video, so it's fine for now. All right, so let's jump into our first visualization. Let's just make a simple bar chart to show the frequency of each type of shot. So we're gonna start out by importing all of the libraries we'll need for this example. That includes Pandas and NumPy for data manipulation, Matplotlib and Seaborn for plotting, and a few extras for drawing our custom court layout later on in the video. Next, we need to read in our shot data. I saved the file right on my desktop, but you'll need to change this file path to wherever your CSV is stored on your computer. Before we do anything with our data, I want to make some changes because I don't like how some of the data was recorded. I want to change the shot type data to be a bit more clear. So I'm going to use the replace function to change 2 and 3 to 2-point shot and 3-point shot. I'm also going to change this result field. It's currently using Booleans, meaning it says true if a shot was made and false if the shot was missed, but I think it will be much more clear if we just say made or missed. So again, I'm going to use the replace function. Coming back to our data set, we have our 2 lines of code with the replace function, and I'll go ahead and print out the first 5 rows so I can see what we're working with. And there's my data. I think this looks much better. All right, now we are finally ready to start writing the code for our bar chart. Like I said, we're gonna create a simple bar chart to see the frequency of each shot type. So the first step is to create our figure using PyPlot. I set my figure size to be 8 by 5. If you haven't already, I definitely recommend taking a look at the documentation for PyPlot. You don't need to memorize all of the features available in this package, but knowing what's available to you can be super useful to help you get your figures to look the way you want. I'll link this documentation in the description. Next, we're using Seaborn's count plot to count the number of shots taken by shot type. I added a title and axis labels, and I'll finish this block of code by showing the figure. So I'll go ahead and run this. And there's my plot. No surprise, Curry is shooting more 3-pointers. So what if I want to take this a step further and see how accurate Curry is with each type of shot? Let's create a stacked bar chart with shot type on the x-axis and accuracy on the y-axis. So I'm going to start by creating a new data frame called accuracy by type. This way I can group the data by shot type and result, and I can calculate the percentage of makes and misses. And now I'm going to plot my new data frame. So we're plotting the fields made and missed as a stacked bar chart. I want shots made to show up as a green bar and shots missed to show up as a red bar. And lastly, I just specified the figure size. So let's just go ahead and run this to see what our figure looks like. Okay, so this figure is fine, but we can make some really quick changes to make it look much nicer. This is where knowing some common PyPlot tools comes in handy. So I'm gonna add a title and axis labels. I also included a limit on my y-axis because my y field is accuracy as a percentage. So it can only be between 0 and 1. So setting this limit on the chart's y-axis will cut off all of this empty space above 1, and it just makes the chart look much more clean. I don't really like that these X ticks are tilted 90 degrees. There's plenty of room on the X-axis to have these fields be horizontal, and it will be much easier to read that way. So I'm going to specify that I want the X ticks rotated 0 degrees. There's so much more that could be done here to customize this chart, but we'll just stick to the basics for now. So I'll go ahead and run this code. And just those simple adjustments made my chart look much cleaner. So we can now see that Curry is a bit more accurate for 2-point shots than 3-point shots. All right, now let's take this even further. We know that our data set contains some spatial data about where Curry was on the court when he took each shot. And we can plot this data over a drawing of an NBA half-court to create a heat map of where Curry was when he took the most shots. The first thing we need to do is make sure that the coordinates in our data set match actual NBA court dimensions. Right now, the shot position data in our data set is based on image coordinates. So we need to convert them. This is actually pretty easy to do. The y coordinates are already correct, so we don't need to shift them at all. We just need to shift the x coordinates to the left by 240 units. So I'm going to define a function here called convert coordinates. And all I'm doing is defining two new variables called court x and court y. Like I said, the y-axis is already correct, so we don't need to do anything with that variable. And for the x variable, all we need to do is take the left field from our data set and subtract 240. All right, now that we've converted our coordinates, we need to draw an NBA half court. I'm gonna link all of this code in the description, so you can just copy and paste it and draw your own half court. It really just took a lot of trial and error to get the measurements correct. But at a high level, I defined a new function called draw NBA court. This function uses simple geometric shapes like lines, arcs, and rectangles to draw every part of the half court. So we have the court outline, the backboard, the paint, the hoop, the free throw circle, and so on and so on. All right, so let's go ahead and print this out so you can see what the drawing looks like. There's our half court. And you'll notice that I hid the axis ticks and I set a consistent aspect ratio so the court looks realistic. And finally, the moment we've been waiting for, let's plot a heat map of Curry's shot locations right on top of this court. So I'm going to start off by adding a little comment here to indicate that this is where we're going to start writing the code for our heat map. And now we are ready to write the code for that heat map. I just called my heat map KDE, which is short for kernel density estimation. This is just a tool within the Seaborn package. So let's just go ahead and break down each argument in this function. First, we are telling Seaborn to use Curry's converted shot coordinates on the X and Y axes. This is why we did that coordinate conversion earlier on in the video. Next, we are filling the contours. So instead of just drawing lines around zones of density, we want them to be filled with color. This just makes the heat map much more intuitive to read. We set the color scheme to reds. I really like the reds color map for this example. It just makes the most sense to me to see the hottest shooting zones emphasized in deep red. Next, we set the bandwidth adjustment to 0.8. The default bandwidth is 1, but I set it to 0.8 to make the heat map slightly tighter around the data points. Alpha is the transparency of the heat map, so I set mine to 60% so you can still see the court lines behind the heat map. Levels is the contour detail. So 100 contour levels is high, which makes the heat map very smooth and detailed. Minimum density threshold can be used to suppress extremely low density areas. So if there's almost no data in an area, it won't be shown. And lastly, we want to draw the heat map on the same axis as the court. So we're setting the axis equal to itself. I'm gonna go ahead and add a title to my plot. And now let's print it out. And there's my heat map overlaid on a custom drawn NBA half court. This is a really nice visual to see where Steph Curry is taking most of his shots. There's so much more you can do with this. You can filter your plot to see only shots made and not shots missed. You can animate a season timeline to see how this map changes over an entire season. You can add annotations or customize your plot even further. Like I said, all of this code is linked in the description, so definitely play around with it and see what else you can do. I hope you enjoyed this video on visualizing Steph Curry's shot data. Make sure to leave any questions in the comments and check out AthlyticZ.com for data science training through the lens of sports. Thanks for watching.